I think when people talk about sockets as tubes or pipes or something, I guess it's kind of like talking about monads as a burrito. It's a little ridiculous. And more significantly, the analogy just starts to break down after any kind of serious use. So I want to provide an explanation that's simple and broad, but then also a demo to really illustrate the point. So the explanation is this. Sockets are an interface that the operating system provides for accessing network functionality, much like the file interface for accessing functionality of storing data on storage devices and retrieving them. So firstly, we want the operating system to do a lot of the heavy lifting for us. We don't want each individual application to have to re-implement things that everyone wants to do, like construct take a message and split it into little segments like we do in TCP and give them sequence numbers and retry them if they fail and so on. It'd be nice for the OS to just take care of that for us. And then secondly, we want the OS to mediate some of the access to the network, because we're in an environment where there are all these different processes. We don't necessarily trust them. And if the OS is mediating access, then we can do things like have the avoid processes arbitrarily sniffing one another's traffic. All right, so that's it. It's an interface for exposing originally network functionality. It's expanded to encapsulate other modes of communication as well, but focusing just on the networking side. The interesting things that we want to do with network protocols, it'd be nice for the operating system to just provide a kind of usable, easy interface for us to do that, much like it does for files. All right, so in this demo, we'll first play with files very quickly, and then we'll kind of extend this idea to sockets. And I'm going to use Python for this. Remember, this is an operating system interface. Well, both of them, the file interface and the socket interface. Python is just providing a thin wrapper. I'm just using Python so it's easy to follow, but you can do this in any language, and you want to think about what the underlying interface is so that you can take that knowledge from one ecosystem to another. Okay, so here I could open a file. Let's say I open it for writing. I can write some bytes to it. I could close it, reopen it maybe for reading, read bytes back. All right. And this is a very simple interface to something that if you stop and think about it, there could be a lot going on here. We could be writing to a temporary file, something that's kind of file-like, like a pipe. It could be a regular file that's on a different kind of device, an SSD or a spinning disk or something. The operating system's managing all of that behind this interface. There are permissions. The file may get large and may need to be split up. We want to cache reads in the kernel, so that in the operating system, so that we don't have to reread unnecessarily. All this stuff is behind the scenes, thankfully. The idea behind sockets is to provide this kind of ease of use to network functionality. So for this part of the demo, here I'm capturing all packets I'm capturing all packets on this network interface, but I'm filtering to show only the ones going to or from this IP address, which I've predetermined is an IP address for Google. So what I'm going to do is open up a socket, establish a connection to Google, make an HTTP request, specifically request the google.com homepage, and I'll do that all with sockets here. Hopefully it looks like a kind of easy. I mean, it's not as easy as going to Chrome and pressing enter, but in terms of a programming interface, we'll see that it's relatively easy to do all these things. And then in Wireshark, we'll see the actual network packets that went in both directions in order to actually achieve what is simple to the programmer. All right, so I'll construct a socket. Again, I'm using Python here, the Python socket module. It's just a thin wrap around the socket system calls. When I'm doing this, what I'm doing is effectively asking Python to invoke the socket system call that you can see with man2 socket. Okay, so I want an AF INET socket, which is an IPv4 socket. I could have also asked for INET 6 or something for IPv6. And I want to use TCP here. So I will say sock stream. INET in combination with stream gets me TCP. Well, really, I'm asking the operating system to construct this socket thing that, if I then use it, will send IPv4 TCP packets. All right. So hopefully I get a socket back. I do. Obviously, nothing's gone over the network yet. I mean, where would it even go? But the operating system has allocated resources, constructed this thing. It gives me back a file descriptor, just like opening a file. But just like opening a file in Python, because it's object-oriented, the file descriptor is wrapped in an object that has methods. And I mean, I can actually, I think, let's see. Can actually see with this file name method what the underlying file descriptor is, but for usability and keeping in Python's kind of object-oriented mode, this S thing is a socket object. But what I can do now is use methods on this socket object like connect. And what this is going to do is invoke the connect system call. Again, part of the operating system's interface, socket interface that it provides is this thing connect, which allows me to establish a connection. So I'm going to establish a connection to this IP address, Google, port 80, which is the pre-agreed upon port for HTTP. So let's see, can I get a connection? Yes. Okay. And at this point, we see something in Wireshark. Wireshark shows us that the operating system has had to if we look at, you can look at either this is my private IP address, this is the Google IP address that we're sending to, or you can look at the ports that are in use. This is going to port 80. My operating system has had to construct this TCP message with a SYN flag, pick a random sequence number, set the headers right, have the correct TCP ports, the right TCP port, but a bunch of other things in TCP that you can drill down into. In Wireshark, the IP header is prepended to that, and then that whole thing is handed over to the network card, which constructs this header. My operating system has also had to respond correctly to this message that comes back with the SYN ACK flags from the server. Send back a final ACK to complete the handshake. There's a lot of subtlety here. The sequence number has to go up by 1. The options need to be responded to correctly. The operating system is, you get the idea. Well, yeah, the operating system is, for instance, timing all of this so that it knows, it has a sense of whether a packet has been dropped or not by taking too long. So all this stuff is done for us. All we needed to do was say connect. All right, so now we have a connection. We can do things like send. So this is going to use the send system call under the hood. By the way, I could also use the write system call, exactly the same system call that's been used here. And because the file descriptor corresponds to a socket rather than a regular file, it would still send over the network. The difference with send is that I have a little bit more control, some more options. Also, Python implements exposes send as a method on the socket. Anyway. So I'm going to send a message now to Google over this connection, and I'll write HTTP. No, I need a request get / actually, if you know something about HTTP, you would expect me to put a protocol version number here. Google actually does correctly respond to no protocol version, which is implicitly HTTP 0.9. So I'll just do this. That means I don't need headers because they didn't exist in the original HTTP version 0.9. All right, so this is a complete HTTP request. Get space / new line to end. Okay, and that's it. That's all I need to write, hopefully. Okay. So I sent a GET request. You saw a whole bunch of stuff go here. And typically it's not going to involve quite as many messages as this. Although, we could be getting a substantial response back. All right, so let's have a look at what happened here. So I'll scroll down a little bit. No, I'll scroll up a bit. Here's my GET request. All right, so we've got the GET / here. But look, I just handed this over to the operating system, and the operating system did what it had to, wrap the TCP and the IP and so on, and pass it along. And then there's a whole bunch of back and forth with the server sending information back, hopefully. We'll see in a minute. And my computer responding correctly with acknowledgements. And then in the end, this just happens to be the very last of the messages there, which Wireshark can now interpret as a complete HTTP response with 200 OK. We got it back. Okay, so as you can see, a lot of work happening. What do we have to do to get the message? We just call receive. Actually, we need to give it a size as well. So let's get the first 1,000 bytes. By the way, this is another value of the abstraction. You could have a very large message, which the operating system buffers for you, and you could populate. In Python, it doesn't really matter because we have dynamic size lists. But if you're working with a language where you need to allocate an amount of space, like Go or Rust or something, you want to say, hey, I've got 1024 bytes or whatever, and that's how many I should get when I call receive. And if I keep calling receive, I get more and more. It's a useful thing to have this kind of indirection between the amount of stuff that arrives at the machine and the amount of stuff that arrives at my process. All right, so let's receive the first 1,000 bytes of the response. And you see HTTP 1.0, 200 OK. And then some of the headers, and if we keep calling receive here, we're going to get more of the response. Obviously, it's nice to have a browser to interpret this as, this is HTML, right? So, or even here, I guess it's JavaScript. To be able to interpret this and display it in the way that we expect to see it. But the point is, we made an HTTP request, we got a response, and that's all it took. There's just these invocation of these functions. A lot of the hard work, really the hard work, was done for us by the operating system, and this was all done in a way where it definitely came back to our process, this Python terminal, not to someone else, and they couldn't without asking and having permission and so on. Right. So hopefully you get the idea. This is the very powerful, very popular socket interface.